All right, 10-4. So we're talking about radical equations. And these are equations that have radicals with variables. They can be solved using these two steps. So first step is to get the radical by itself. That's what isolate means, be by yourself, like if you isolate in your room. Isolate the radical on one side. That's the first step. Second step is to square each side of the equation to eliminate the radical. And something I'm going to say over and over today and tomorrow is that radicals and powers cancel each other out. So we're even going to write that down. Radicals and powers cancel. I want you to write that down. Each other out. Just like when we would do like 4x equals 12. This is 4 times x, so multiplication and division cancel each other out. So then x would be 3. The same idea here is that radicals and powers cancel each other out. So here's what I mean. Step 1 is to get the radical on one side of the equation. Get the radical by itself. So here it is by itself. Second step is to square each side to eliminate the radical. So this is the radical, and the opposite of a radical is to square it. So we'll square both sides. So the radical and the power cancel each other out, so we just have a equals, now we need 8 squared. I can use my calculator if I'm not sure. 8 squared, or 8 to the power of 2 is 64. And that's it. You could check your answer just to be sure that you're right. I'll do it in pencil, so you don't have to write this down, but I just want to show it to you. Check. So we could make sure that the square root of 64 is equal to 8. I'll put a question mark there. And in my calculator, I could do square root of 64 is 8. So it works. All right, next example. This time we have the square root of a plus 6 equals 32. So if I go back to my steps, step 1 is to isolate the radical on one side of the equation. The radical is on this side, but it's not isolated. It's not all by itself. So I will subtract 6 from both sides. Now I have the square root of a is 32 minus 6. Well, if you weren't sure, you always can use your calculator. Looks like it's 26. It's by itself now. And then the second step is to square each side of the equation to eliminate the radical. So I will square this, put it in parentheses, and raise it to the power of 2. The radical and the power cancel each other out. Radical and the power cancel each other out. So we have a equals 26 to the power of 2. 26 to the power of 2 is 676. 676. So now to check my answer, check it again. This is just in pencil, so you don't need to write it down. Check. Square root of 676 plus 6 equals 32. Let's check it. Question mark. So the square root of 676 is 26. Okay. So 26 plus 6, does that equal 32? 26 plus 6, yeah, 32 equals 32. Sweet. We know we did it right. All right, that's our first 2 examples. Example number 3. This time, we want to do this a little differently. So this is 2 times the square root of x equals 8. And if we're going to isolate the radical, step 1, we need to get it by itself. This is 2 times, so we can do division first. The square root of x is 8 over 2 is 4. The radical, once it's by itself, radicals and powers cancel each other out. So to cancel it out, we raise it to the power of 2. Then we have the square root, oh, sorry, well, they cancel each other out. What now? We'll fix that. So the square root of x squared is just x equals 4 squared. I know that one. 16. There we go. I'm not going to check this one just because I want to get to the other examples. All right. So that was the first 3. Hopefully not too bad. Example number 4. This time, the radical is by itself. Even though there's stuff underneath it, the radical is the only thing on this side. So I'm still going to raise this to the power because radicals and powers cancel each other out. That's what we've been talking about. So I'll raise it to both sides to the power of 2. Well, 7 squared, or to the power of 2, is 49, equals that radical. Once you square it, we just have those cancel each other out. So we have 26 minus n. 26 minus n. Well, now we're trying to get n by itself, so I can subtract 26. 49 minus 26. 49 minus 26 is 23. 23 equals negative n, and then to get n by itself, we got to divide by negative 1. Because this is like a negative 1 in front of it. So negative 23 equals n. There we go. Let's check this one. I want to see if we did it right. So to check it, we go back to the original equation. We have 7 equals square root 26 minus negative 23. Notice how I plugged it in with the negative 23 for the n. So first I'll do 26 minus negative 23 is 49. So I want to know, is 7 equal to the square root of 49? Well, what is the square root of 49? Try it. Square root 49, 7. Hey, there we go. We got it. Alright, we'll do one more of these before we turn it over. On this example, we will square both sides again. The radical is already by itself. And I'm pretty sure there's going to be one of these on our quiz on Friday. So now I have x minus 4 equals 36. Oh, just one step to get x by itself. Add 4. So this time x is equal to 40. There we go. A review of our steps. Step 1 is to isolate the radical. Step 2 is to square both sides because radicals and powers cancel each other out. Alright, let's flip it over. On the back, extraneous solutions. Okay, this one sometimes can be a little bit tricky, but it's really not too bad. So step 1, isolate the radical. That's just like on the other side. Step 2, square each side. That's just like we had on the other side. Now there's just a couple other steps. Step 3 is to continue to solve for the variable. So if you have a variable with the power, you put it in standard form. And then you can find the roots using one of 3 ways. I will explain this more as we kind of get into it here. So we'll start with number 7. Step 1 is to isolate the radical by adding, subtracting, multiplying, dividing. We want the radical by itself. So here's my radical. It's not all by itself because I have this plus 3 here. So I'm going to subtract 3 from both sides. And then I have the square root of 10 minus 6k equals k minus 3. To get this by itself, I need to square both sides. So there it is squared. Because, oh, I should write this down on this side. Remember, radicals and powers cancel each other out. So here's my radical, here's my square, they cancel out. So all I have is just what's left in the middle. The 10 minus 6k equals k minus 3 squared. Okay, if I pause for a second and just kind of look at what we have, without even going to my steps, if I look at this, I bet a lot of you are thinking even the same thing. K minus 3 to the power of 2, we can solve that, but we do it by foiling, which you guys all know my math teachers never let me call it foiling when I was in school. So this is really like distributive property. We distribute these. The squared means that you write it twice. That's why I wrote it next to each other. K minus 3 times itself. Then we multiply the first part by the second part. So this will be k squared, and then we have k times -3, -3k. Then I have -3 times k, again, which is -3k. Then I have -3 times -3, which is +9. And the stuff on the left, I didn't really change it, so I'll just leave it there. 10 minus 6k. Okay, so far we got the radical by itself. We squared both sides. We FOILed it. And this is where we're at right now. We need to get this into standard form. So I already have some numbers over here on this side. And I want to kind of get everything that I have right here over on the other side. So I'm going to do that by adding 6k to both sides. And in the same step, I think it's easier just to do it all in the same step. I can subtract 10. So on this side, if I have 10 minus 10 and 6k plus 6k, I should have 0 on this side. I did that on purpose. I want it to be a 0. Over here, I don't have anything with the k squared, so that stays by itself. Then I have -3 minus 3 plus 6. So, okay, let me try this in my calculator. -3 minus 3 plus 6. Hey, that's 0. So all these things right here, they cancel out. Next, I can do this plus 10 minus 9, or plus 9 minus 10. That's -1, so k squared minus 1. Whew! That's kind of a lot of work just to get to that step. But once you get there, this is all stuff you know before, and this is what I love about math, because it all builds on each other. If you're looking at this, we did this back in chapter 8 with Magic X. So in my steps, it tells me I have 3 methods now to try to find the roots. I could factor it. That's like Magic X. I'll write that down, Magic X. You could graph it, or you could use the quadratic formula, which is that big, like, x equals, the pot goes the weasel song, -b plus or minus the square root of b squared minus 4ac all over 2a. Okay. I know you guys are singing the song now. But once you have those 3, or you can pick which method that you want, any way that you want to do it. I really don't care how you want to do this. I feel like graphing might be an easy way to try it. Try to find the solution, so especially for this one, like we could try to graph it. So now it would be like y equals k squared minus 1. So here's k to the power of 2 minus 1. Graph it. And hey, there's my roots. So I could make sure that those are like perfect numbers. I go into second calc, but actually all these will be, so I don't need to do that. So it looks like my zeros are at -1 and 1. So here I have k equals -1 and 1, because that's where they cross on my graph. My graph looks like this. They cross right here at -1, 0, and 1, 0. Okay, so that's the first kind of set. This time I am going to make you check your answers. Check your answers by plugging them in. Some may be extraneous. Extraneous means like extra, where they don't actually work out. So to check it, I'll draw a line underneath here. Check which is required. And you plug it back into the original equation. So if I go all the way back up here to this original equation, square root 10 minus 6k plus 3 equals k. I'll zoom out a little so we can try our check step. So I have the square root of 10 minus 6. Now for k, I'm going to plug in -1 and keep my square root extending all the way over that, plus 3 equals, I'm still going to plug in -1 on this side. So if I solve this out, this will be the square root of 10 minus 6 times negative 1. So 10 minus 6 times negative 1 is 16. So square root of 16 plus 3 equals negative 1. So what is the square root of 16? Use my calculator. Square root 16 is 4. 4 plus 3 equals negative 1. What is 4 plus 3? 4 plus 3 is 7. Uh-oh. Does 7 equal negative 1? No. That's why we have to check our answers. So that is actually not a solution. So this is negative 1 is not a solution. Okay, let's try our other example. So negative 1 actually doesn't work. So now we could try 1 and see if that one works. I'll try it with blue. Square root of 10 minus 6 times 1 plus 3 equals 1. 10 minus 6 times 1. So square root 10 minus 6 times 1. I'm going to type the whole thing in, is 2. Does 2 plus 3 equal 1? Two plus 3 is 5. Does 5 equal 1? No. So 1 is also not a solution. So this graph, even though when we solved it out we got no solutions, this one has no solution. I know it seems like, wow, why did we do all that work? We did all that work to try to see if there was, but it really didn't work it out. Okay, if we keep going and we try one of these other examples, I'm going to just draw a line down the middle here. We'll do this one. This will be our last example for today. To square both sides, again, we'll have 3a minus 2 equals a squared. Now in this step, once we have that, it's an a squared, so we got to get everything on the same side. It needs to be in that standard form. Ax squared plus bx plus c. I'll zoom back in so you can see here. So subtract 3a, add 2, subtract 3a, add 2. So this time it's 0 equals a squared minus 3a plus 2. And again, we could solve this a couple different ways. We could graph it. You could do magic X if you wanted. You could do quadratic formula. If we tried to graph it, we would type in x to the power of 2 minus 3a, or 3x, plus 2, and graph. And this time my zeros are 1 and O. I don't know if that's exact or not, so let's do second calc. I'm going to calculate a 0. We'll go to the left, then we'll go to the right. So I got x equals 1, okay. Well, a, I guess. A equals 1, and then let's find the other one. Second calc, 0. There's to the left, and then to the right. 2. Oh, good, they were nice. 1, comma 2. Now to check it, we'll check the first one. We want to know, is the square root of 3 times, we'll plug in 1 for a, minus 2 equal to 1? Well, square root of 3 times 1 minus 2, let's try that on my calculator. Square root 3 times 1 minus 2. That's 1. Because this is 1 equals 1. So it works. Hey, that's good to know. Okay, now we got to check the other one. So this time I'll do it with magenta. Square root of 3 times, we're not doing 1 this time, we'll plug in 2 minus 2 equals 2. We're not sure, so I'll put a question mark. Well, back to my calculator. I want square root of 3 times 2 minus 2, close parentheses. Hey, that's 2! This time they both worked. So those are both my answers. This last example I'm not going to do just for the sake of time, but I bet you could guess this one. Our first example, neither of them worked. In this example, both of them worked. In the next example, neither of them work. So there you go. Good luck.